Okay, so I'm Western Washington FSR Jamin Meyer. Excuse me. You can reach us at this is text services line 253-620-8282. Again, if you do not have this number programmed in your phone, please do it now. 253-620-8282. Call or text. I'm a big fan of text. To get a hold of us, the quickest way is probably take a picture of the data plate of the unit you're working on. Text it in to text services with a brief description of what you got going on. It automatically puts you in the queue. That way, we try to get back to everybody within a 20 to 30 minute window. So again, texting a picture in, we're all from the field, your FSRs here at Gensco. So we appreciate pictures because I need to see what you're working on. I want to get my hands in there too and whatnot. So pictures are very helpful. And then if you take a picture of the data plate, it's legible and there's no discrepancy in what model number you're running off with. Today, I just wanted to define what we're going to be talking about. The variable speed systems. We have the variable speed 18 and 20. The vertical discharge, they were launched in 2013. They got the one-piece drive. The variable speed 19 discharge, side discharge, sorry, this guy launched in 2018. It's got a two-piece drive, the MOC and the AOC. MOC is the drive itself. Here's all the communicating equipment you can put with it. If you want a copy of the slide, feel free to mention that in your message or whatnot, but I'm not going to go too deep into that. I just wanted to show it so you know what's there. Installation clearances are minimum 6 inches from the exterior. 2 feet required from front of the service panel for airflow. We have had halfway blockage of railroad ties possibly getting stored in front of it. Be aware that output air will backdraft, and there's an outdoor air sensor right back here that can be relocated if need be. But keep that in mind. Air is, if there's something obstructing it, it's going to push back and affect that ambient sensor. Again, we want 3 feet. I've gone out on site visits where we have a wall right there. We're not able to get that access. So we want a 36-inch minimum to that electrical. You got your compressor in there and everything. So keep that in mind when placing these units, and 12-inch clearance above it, 2-inch minimum. Line set lengths, 150-foot max. That's almost for all of them with the 50-foot vertical. So that's a pretty long line set. I borrowed this slide deck from Mark Alkire, so he took a lot of these pictures in the field. What's missing in these installations, I just want to stress the fact that when we start icing up in our area, we need pump ups underneath. We have to get pump ups underneath, or else that defrost, the condensate will refreeze under there and end up lifting the unit and possibly breaking the welds. So we want a minimum 3-inch elevation underneath that for when we're defrosting and melting that ice, where we have proper drainage down here. I like to touch on the line set sizes because there is no 1 1/8 3/8. So be aware, we can run a 3/4 for a 5-ton variable speed site discharge. See, this is all in the installation manual or on your comfortsite.com or ASDealerNet. Again, variable speed outdoor units require the indoor unit be configured at 400 CFM per ton when charging, which I'll touch on that a little bit more. Here's our charging, total line set length, total vertical charge lift, design subcooling, final subcooling value. We always want that right around 10 degrees subcool. I put this in here from variable speed 19 installation instructions. Again, if you notarize that in the installation manual, good for you. I used to write my numbers on the backside of the panel on my date of startup, my total line set length, and how much I added refrigerant wise. In the installation manual, it does have a 0.6 ounce per foot adder. We do not recommend this method. And why we do not recommend that is because I have it on the next slide. Installers should not add charge prior to startup. Installers should fire off the units using the variable speed test mode with the factory charge only released to evacuated lines and coil. So what we're going to do is we're not going to do the line set adder. We're going to release the refrigerant, and then we're going to put it in check charge mode, heating or cooling, and we're going to wait for the control to time. It's 20 minutes, and then we're going to add charge. And then in heating, we're going to use the pressure temperature chart. And that's below 55 as stated in this. So we're going to use our pressure curves in heating below 55 degrees, and above 55 degrees, we can use cooling to get a total subcooling charge. Charging and subcooling above 55 degrees outside temperature and a 70 to 80 degree indoor temperature. As you can see, this is our total linear feet. Use design subcooling. That design subcooling is going to be listed on your data plate. This one says plus or minus 3 degrees, so it's 10. So it could be up to 13, up to and down to 7 degree subcooling. So keep that in mind. They are going back to the plus or minus 3 degrees, but usually our target window is 10 degree subcool. So always refer to your data plate or your desired subcooling. In October, I'm going to have another quick hitter that we're going to dive deeper into the heating side of it. Right now, we're going in the cooling season, so we're going to be charging per subcooling, which is the 10 degree subcool. Always check your data plate. But for check charge mode heating, we're going to go off of the pressure curves. So I'll slightly touch on that because I'd like to, the guys calling in that have never used the pressure curves, once you learn how to use them, it really eliminates a lot of question and speeds you up on your install. If it's 45 degrees out, you follow the line up to intersect. If you could see the 60, 70, and 80 degrees represents the indoor temperatures. Right here, it's 3 lines. Right here, it shows as one solid line because they're so close. So your suction, 45 degrees out, your suction should be about 90 degrees or 90 PSI. And then 45 degrees, and you have this line 60, middle line 70, top line represents 80 degrees indoor. So if you have a 70 degree indoor, reference the middle line, 45, it intersects with the middle line, your head pressure should be about 360. So we're going to get them as close as possible to the pressure curves. And again, in October, right before heating season, I'll go deeper into using the pressure curves so everybody can get savvy with using the pressure curves. We're going to go through the 1050 and 850 setup. They are both the same thing, but the 1050 is bigger and meant for zoning. You cannot connect zoning on the 850. You can only connect zoning on the 1050. Here's our communicating controls at this time. Everything is using the 2-wire data, brown and blue, and everything's communicating. We're not using the red unless we're hooking up a generator. So you got your brown and blue connected to the outdoor unit. That goes for all the variable speeds. There is a diode in the low voltage harness protection. So if it does get a high voltage, it's possible that diode is faulty. So what we want to do is we want to take a reading across our data and our blue right at the drive control itself, which I'll have a picture of that in a little bit, just to confirm that it is putting out the 16.5 volts DC. All units come with the filter dryer, so install filter dryer, please. This is a good slide that shows good communication between brown and blue, the data and the blue, data in common. It's going to be 12 to 13 volts DC when everything's connected. It'll show 16 volts DC if it's open, if it's not connected, or if it's connected and we have a short in the wire. Here's a shorted comm, 0 volts. So this is a good slide that we send out a lot to guys calling in for communication diagnostics. I mean, it's pretty straightforward. You got 2 wires. That's your brown wire, or data is your brown wire. B is your common blue wire. We're connecting it to our red, and blue is your 24 volt for the display, so you can actually navigate. I put this in here because we want to stress the importance of relay panel with an S9V2, communicating S9V2. So we have a communicating control. I get this a lot. We're still getting a lot. We trip out on high head pressure. We run our communicating wires into the relay panel. Here's our S9V2. We have to energize this BK terminal and then cut the BK jumper. We have to do that at the indoor unit. What it does if we do not connect that BK terminal is the furnace will not ramp up with the compressor. So we'll ramp to 80% and the fan speed will still be at 50% and we'll trip out on high head. So we have to cut that BK jumper in order for the compressor to operate the indoor fan speed. So if the compressor is running at 80%, the fan speed is going to be somewhere near 80%. So please always connect that BK and cut the BK jumper. And for the BK, you have to have the 1050 or the 850. CFM must be set at 400 also with the S9V2s. S9V2s, the factory default is 350 per ton in cooling. So you have to get in the menu and change that to 400 CFM. So here's our installer setup. Installation wizard is going to prompt you for the first time. So we're going to go through, we're going to set up date and time. We're going to go through installer setup next. So first thing you're going to do is set up date and time. Group 1 standard settings. Now, if it's communicating, all of this is going to be picked up. You're going to have the air handler, but we got to tell if it has. We have to tell if it's electric or gas and oil. So if you're dual fuel, you're going to do gas. If you're heat strip, you're going to do electric. And if you're doing the hydronic heat strips, you're going to have hydronic. And then we are variable speed. So we're always going to select variable. So that's something that you're always going to have to select. Group 2 equipment settings. You're just going to leave these in default unless we start needing to change things, but hardly ever do we have to change the cycles per hour. Group 3 is your sensor settings. Select outdoor temperature sensor. This is where we're going to select, do we want to use the outdoor sensor in the outdoor unit, or do we want to use online weather, or did we wire in a separate outdoor sensor to the relay panel? It's mostly common to just use the outdoor ambient sensor located in the outdoor unit. Keep in mind, if we do select online weather or internet weather, it's not necessarily at the site. It's could be from an airfield or your local school. So it could vary quite a bit from your actual location. And also, during defrost mode, it does not use internet weather. It uses the sensors on board the outdoor unit. So that's a key point right there. It's always, for operation, it's always referring to the onboard ambient sensor in the outdoor unit. Humidity sensor, you can enable or disable. Humidity controlling, select the zone. Group 4 accessory settings. So we always want to go and tell it what filtration type installed. Do we have a communication air cleaner? If it is communicating, it should pick it up right away. Do we have a media filter? Number of air cleaners installed. So if you're doing a double side tap and you have 2 air cleaners, you'll change that to 2. And then humidifier installation, humidifier fan action. Do you want the humidifier to come on with a heat call? airflow during humidifier mode, so we can change the percentage of airflow. Again, you cannot change the percentage of airflow if you do not have the BK jumper for the S9V2. So keep that in mind. You have to have that BK terminal wired in to be able to control the percentage of fan. Is there a UV light installed? This is accessories continued ventilation installed. If we have a fresh air damper, we're going to choose yes. And if we have it wired into the TAM9 auxiliary contacts to close the contact, so either you could change it from normally open or normally closed. Do we want that fresh air damper to come to open up and then indoor fan to run? Outdoor temperature ventilation override, so we can select an outdoor temperature override. Ventilator fan action, ventilate with blower, ventilate without blower. Most of the time it's with blower because we want to bring in fresh air. We can actually change. So if those get tricky, if we have a manual air damper and it's stuck open and it's 20 degrees out and we're pulling in 20-degree air across that coil, mixing with the 70-degree room in temp, and we're getting like 46-degree return air, we can shut that and make sure we're not pulling in 30-degree air by changing the settings. That way it uses the outdoor temperature sensor. If it's below 30, it will not do makeup air. So keep that in mind. There's a lot of options in the accessory settings. Feel free to ask any questions in the chat line too. FSR Jeremy was going to join us here in a little bit to answer any questions, or I will try to answer them while I'm running through, or we'll get to them at the end of the slide deck. Group 5 comfort settings, enable dehumidification. That's enable or disable. Again, if you have it, you're going to enable it. Smart continuous fan, you got your control response rate, aggressive recovery. We don't recommend enabling that in dual fuel applications because it's going to turn on the gas furnace quicker. But when you have a heat strip, it'll take 15 minutes to engage that heat strip. So if you enable that, it'll bypass that 15-minute time. So if you do have a homeowner that wants that quicker heat, if they're coming to 65 to 70 from nighttime setback, and we got a 5-degree rise, it's going to take another 15 minutes because it's going to click to 65 to 70. It'll take 15 minutes before that, possibly 15 minutes, because if it does raise a degree or two, it's not going to energize heat strip quite yet. So some homeowners want that quick heat. So we want to satisfy that room temperature as quick as possible. That way we can use the heat pump at a lower speed going forward. So that aggressive recovery does come into play quite a bit. We can actually heating aggressive recovery when it gets colder out. So we can set that at certain temperatures too. So we have a lot of control in there. Warm air discharge, when enabled, the indoor airflow will be limited to 80%. That just says it's going to start at a lower speed to let that coil get nice and warm. We're still in lockout settings. Here's quiet mode. Keep in mind, I deleted some slides because of time, but quiet mode we want to enable. And the nighttime setback comes factory default for 0%. So that means if somebody did turn on quiet mode, then in the nighttime, it would run at its lowest setting, could be 30% or 40%, depending on what unit, and therefore never heating the house up to temperature. So we've gotten complaints on that. So we do recommend going in, changing your quiet mode nighttime setback to 100%. And then disabling it. If you want to know more about that, feel free to question that, and I'll get back to you after the slide deck here. But I'll touch more on that in October. Auxiliary heat lockout. And again, we can lock out the heat strip from coming on at higher temperatures and wasting electricity. If we don't want the auxiliary heat to go above or come on at 45 degrees, we just want heat pump. we can do that there. Compressor heat lockout, this comes into play. If we have heat strip backup, we don't recommend enabling it, but if we have a dual fuel setup, that's when we're going to enable this and possibly lock out the heat pump at 40, 35, 30 are pretty common outdoor temperatures to lock out that compressor heat. So that just means that the gas furnace will run at that time. If we have 3 stages of heat strip, we can actually lock out each stage of heat strip. So we could say we only want the 5 kW to come on at 40. We want 10 kW to come on at 10 degrees, and then 5 degrees, we get all 25 kW of heat strip. So if we do have an energy conscious homeowner, we can actually save them a little bit of power. They lose some comfort, but they're saving electricity. We can do that with the furnace heating also, and the compressor heating. Well, here's our quiet mode. Does not display characteristics. When active, quiet mode symbol would be displayed on the 1050 home screen. Quiet mode is the percentage demand. Heating and cooling mode, quiet mode limits compressor operation, heating and cooling mode, percentage demand to meet local sound requirements. Here in Seattle, they are pretty picky on quiet mode. So this really saves us in the city of Seattle, because they're making guys go back on jobs that have been inspected a year prior and relocate units because the neighbor complained that they're too noisy. But with our variable speed, we can access quiet mode and actually cut that compressor demand at night. That's where that nighttime setback comes in. So the compressor is not as noisy and it meets the sound requirements. So keep that in mind. We can do a lot with that. And here's our Washington State code at this time. That's pretty low. And here's our settings for the new quiet mode. Well, it's not new anymore. We're going to go into system mode. Systems options, enable. Well, you can see that it's enabled quiet mode right there. So if we are limiting, or if we get a call from the homeowner, the system not keeping up at night, we see that the quiet mode is engaged, we might want to go in there and adjust the settings. Here's how we set it from set quiet mode from installer setup. Press menu, press your service. We're going to go into installer setup. You're going to go to lockout settings, group 7 of 7. You can see that that's factory default. It comes 0%. We're going to select night, press the demand to 100. Next. Now we have 100% and done. Here's our service enclosure. Here's our AOC. This is on the side discharge. This is the MOC drive itself. If you do have to replace one, there's a link on fieldtechhelp.com that has a tutorial video, 5-minute tutorial that you can watch, and it shows you how to replace those. That way you can see how it's done before you get out to replace a drive. There's our vertical discharge, one piece with the, AOC on top. You can actually remove this and swing it out so you can access it. You can see the top AOC and MOC. This is all one unit that needs to be replaced if it's bad. Same with the drive. Here's our stepper motor. I always confirm the stepper motor is nice and snug on there through transport. I always make sure our coil sensor is in that location through transport and vibration and trucks that lose their suspension. Those things kind of take a beating sometimes, so they can jar loose. Can be done remotely through remote contact once the homeowner approves the connection. Can this all be done using link? Yes, the link will be remotely, but today we're talking about the traditional variable speed. But yes, with the link, new equipment, it will be, if they are connected to Wi-Fi, it will automatically update system over Wi-Fi. And if they're not connected to Wi-Fi, you know, some homeowners don't want to be connected, you will be able to do it on your service, yearly services. You'll go out there and you'll update it from your phone. Once you connect Bluetooth into the system, you'll see that there's a software update available, and you'll go ahead and do software update and it'll transfer it from your phone. So it does speed up. The links are pretty cool. So hopefully if you guys haven't attended a links training, you can put that in the messages too, to contact your sales rep, and we'll try to get you a links training scheduled for you. Again, we're in the variable speed site discharge control box. They put the critter prevention on there. The earlier models, we had a lot of critter issues. We have our service ports down here. Again, some of them I've seen that pipe that's pretty close right there. Just finesse it out of your way. I apologize for that, but yeah, there's some tight ones in there, that's for sure. Our pressure cutout, we have our suction temperature sensor, suction transducer right in there. And again, this is our true suction, so we always want to be gauging up to true suction. We still get calls from guys in the field in heating mode. They're gauged up to our service valves. Again, any new guys out there, this is our true, this is our true suction down here. You want to gauge up the suction side, your blue hose line, to our true suction port, because down here we're going to register the same pressures and heating. The variable speed drive serial number, if we do have to replace a unit, keep in mind we need a picture of this drive serial number for warranty purposes. And here's our test. I got a better picture of our test pins down here. Here it is right here. If we're diagnosing a drive, I'm going to ask you for our volts DC from the test pins in this location. You can see that a little bit better picture without the probes, but keep that in mind. I always refer your attention down there so I can get a test point of what our voltage DC is, usually right around 333 volts DC to 375 volts DC, normal operation. Here's our high voltage line. So we might ask you to want to know what that voltage is actually coming to our system to make sure we got a good 220 volt. And then here's our 3-pin compressor. I might ask you for a volt reading at the compressor pins. When we're testing compressor resistance with the power off, we're going to take our readings right at the compressor. We're also possibly going to test the harness. So that does pull right off, again, with the voltage off, with the disconnect off, and wait a couple minutes for the power to subside. Those capacitors in this drive do store power. So even with the power freshly disconnected, it is possible shock. Let's get into the site discharge variable speed control. That's what it looks like without everything bolted to it. And there's our cooling loop right there. When installing a new one, you're going to put that heat sink paste in there, and then resecure it. That's what the AOC looks like. Sometimes we get a bad harness, so we want to always double check these connections. With the power off, I like to pull these connections, put them back in, and then push the wires all the way in to make sure we got a good solid connection. Here's our board. Here's our CDA, EV stepper motor, our voltage. So we'll have test pins right there, 18-pin connector with all of our sensors. I'll go into that. Here's our personality module, our switchover valve, reversing valve. We can force a defrost if need be from button or go cycle through our CDA. Our outdoor communicating CDA. So this, we still get a lot of questions. Guys have not gone through this. So I just wanted to go through everything in here. If we press and hold the top and bottom button, we're going to press and hold that top and bottom button until it displays monitor menu. So it's going to start out monitor menu. Now you can either go right or left. In this diagram, we're going right. So we're going to scroll right. It's going to show our alert menu, and that's going to have our active alerts. The alert history menu, if we scroll one more right, so monitor menu is always going to show up first, our alert history menu. So we want to go through there and log what our alert history is. Configuration menu is where we can actually change some parameters. So we might want to go in there. I'm going to show you what to change in there, what we recommend, and then our control menu for testing. So we get into the control menu quite a bit. From monitor menu, again, we're pressing and holding the top and bottom button, and then it's going to display monitor. So now we're in monitor. We're going to scroll one down to system, and then we're going to scroll right. And now we're just going to be peering into the system sensors. So from this, we're going to see compressor demand. In check charge heating and check charge cooling, this will show 0, just so you know. But if we're in normal operation, we're going to be able to see what the actual compressor demand is. We can see our compressor speed. We can see if the switchover valve or reversing valve is in heat or cool. We can see if we have load shed connected. Here's our ambient temperature. This is for future use. We don't have that connected yet. I'm sorry. We're going to be looking at our coil temp in the outdoor unit. This is just looking at the outdoor unit. Again, TAM9s, I did not put the slide deck in for TAM9s, but the TAM9 menu is pretty similar to this menu. So keep that in mind. You can look at all the TAM9 sensors also. We can see our suction T-sense, our suction pressure. So if you have your gauges hooked up, I like to compare that to what I have on my gauge. So keep that in mind. We have 110 on our suction pressure on our gauge. We should be right close to 110 on your suction pressure. We can see our superheat. We can see our liquid. How long does it take for capacity to discharge? How many minimum? How long does it take for capacity to discharge? As far as the sensors, I mean, they activate pretty quick. 3 to 5 minutes under 32 volts DC. Okay, Jeremy's got you. Dome temp, that's our compressor dome temp. I like to confirm that dome temperature sensor is secured, fastened onto the liquid discharge line on the compressor. I have seen those rattle off. And then on the vertical discharge units, that dome temperature sensor is going to be located right on the top of the compressor underneath the insulated compressor sack. So if we do have an issue, we will have an alert for that. And so please double check that compressor dome temp. We can see our outdoor fan motor RPM. Here's our EEV positions. 500 EEV position 500 is all the way open. 0 is all the way closed. Our drive. So monitor menu, we went down 1 and over to the right, and now we see our system. So if we go from monitor menu to system, scroll down 1 more, is our drive. So now from drive, you press right, we can see our compressor watts, our incoming line voltage, our DC voltage, our drive amps, inverter temp, rectifier temp. So we get into this sometimes, so you can actually compare that DC voltage. From drive, you can scroll down, see system tachometer. So we can see system runtime, cycle count. So a lot of information in this. Our technician, okay, so from monitor menu, we scrolled one right to active alerts. And it's going to give us our active alerts that we can go through and log down, right? So if we're communicating thermostat, we always want to log what we see on the outdoor unit. And a communicating thermostat, we're going to go into alert history too, and it's going to give us a explanation of the alert and possible causes. And then if we scroll one more right, we are into alert history. And this is where we want to go log our alert history. And then I like to clear alerts before we run drive tests, just so we don't have any confusion, or if you have to reset the unit, or you're going to want to clear alerts. Configuration menu. So again, we're pressing and holding the top and bottom button till it displays monitor. We've gone through alert history, and now we're at configuration menu. From configuration menu, we're going to scroll down. We have that external switch. I don't see too many people using it, but that's where we're going to access it if we have a generator relay connected. Minimum airflow. So we can actually change, this is going to change the airflow indoor. So if we got a complaint of too low of airflow, we can actually change that minimum airflow to 50%. So we get more air out of the indoor unit, more CFM. Heating max RPM, we usually do not have to change that. Oops, sorry. Defrost termination. This is one thing we do recommend setting to high in our area. Factory defrost termination terminates at 47. So what that means, for defrost to engage, the outdoor temperature has to be below 52 and the coil temp has to be below 32. So it's referencing the coil temperature at 32 degrees. Once it initiates defrost, that coil temperature needs to reach 47 degrees. And what we've seen is that 47 degrees doesn't get all the ice off in our area. So when we set it to defrost termination high, it's going to defrost a little bit longer until that coil temperature sensor reaches 67. And in some cases, it's up to 70. So what that means is that defrost is going to run just a little bit while longer, and it's going to eliminate all that ice. So if we do have a defrost ice buildup or frosting issue, let's set that defrost termination the factory high, from factory to high. So you're going to cycle over 3 over and then press the center button, and it's going to save it. You'll see the little check mark near high. So please keep that in mind if we're having some ice, or just go ahead on new installations, set that defrost termination to high. We have our cooling blower off delay. So we can actually change that from the outdoor unit also, or tell it's none, but we can change that from the thermostat settings also. Indoor air, it's going to come set for comfort is our factory efficiency. So in heating mode, this does come into play a little bit, because in heating mode, comfort lowers the fan speed of the indoor fan to collect more heat across that coil. So we get a higher delta T or higher supply output. Efficiency will speed the fan up, so we have more CFM going over that indoor coil, which assists the compressor to work less. So if the compressor is working harder, that leads to more wattage usage, so more power consumption. So efficiency speeds up the indoor airflow to lessen the compressor usage, leading to more efficiency. So keep that in mind. We have seen a couple systems come from factory set for efficiency, and our static could be too much, or we're not getting a good delta T. You may have to go in here and adjust it to comfort to lower that indoor fan speed. So keep that in mind. PFC is power performance correction. You shouldn't have to touch that. That's for limiting your compressor. Your EMI, we've had some flickering light issues, so you can try to select EMI off. It does take away, just changing the EMI setting from auto to off will alter the switching frequency during higher speed compressor operation. So it's going to affect that compressor when it's 90 to 100% compressor speed. And then you can always restore default if you've gone through settings and you need to restore default. Our control menu. Again, you press and hold the top and bottom button. So it says monitor. So from the monitor menu, you can either go 4 right or 1 left. Here's our control menu. So if we are having an issue with the drive or the outdoor fan, or we can test the EEV, this is what we're going to do. We're going to press 1 down. We're going to run drive test, because we're just going to press enter, and it's going to come up testing. And this will come back past no fault. It'll detect the windings. It'll see if the compressor locked rotor failed drive hardware. So we ask for this quite a bit if we're having any suspect drive issues. We can run outdoor fan test if we had some kind of high current, possibly not defrosting correctly and ice buildup, or if we have a bush in the way or overgrown vegetation blocking the coil, or a bunch of cottonwoods on the coil. We can run that outdoor fan test, and it ramps up all the way up to its maximum RPM. So if we do have an issue with the outdoor fan motor, we have a test we can do. We can do a forced defrost. We can also do this from the thermostat while in test mode, or the button on the drive itself. This is an important one that we do. EEV test, we can drive that all the way open to 500. We can close the EEV test and actually watch our pressures to confirm if our EEV body is opening and closing. Also, this confirms that our stepper motor is working correctly too. So instead of testing it with voltages or ohms, we can go right ahead and test it through the CDA. So it speeds up the process a little bit. We can also test our reversing valve and heating and cooling and watch our pressures. So that's another test that we can confirm by watching our pressures to see if we get a pressure change by the switchover valve going to heat or cool. And then it'll display test in progress, test complete. If we have to do a pump down and get the refrigerant back into the compressor by closing the liquid line and pulling all that refrigerant back in the compressor, we can do that. And what it's going to do is it's going to open all the EEVs, indoor EEV2, so we can go ahead and get all the refrigerant back into the compressor. Number of sensors connected to the drive using the 18-pin connector. Now in the service facts, I'm going to go through it because this is important. There's only 5 sensors in these units. In the Link, there's going to be 7, but there's only 5 sensors in here. And once you get fluent with checking sensors, it's a no issue, and you can rule out a lot of information pretty quick. And we're going to ask you to do it. Here's our chart. This is in your service facts in the outdoor unit. If you don't have the service facts on site and you need it, please call tech services so we can email it to you, or we can send you the snippets from this. But this is pretty important. Here's our discharge temperature sensor. It's going to show us actually, and that one has the color codes. I'm missing some parts in this because it'll tell us exactly where the discharge temperature lands on this pin right here. And just, it could be, that's usually mounted on the right-hand side. So we're going to go off of our pressure temperature charts right here for disconnect power. Excuse me. Ambient temperature, number 5 and 14 black wires. If we disconnect power and it is 70 degrees out, and we're taking the readings across, once we disconnect it across pins 5 and 14 with nothing attached, it's going to register 11,717 ohms. I like taking volts DC because I can leave everything powered on. So I'm going to go across pins 5 and 14. Volts DC, if it's 70 degrees out, it should be at 0.68 volts DC. So all these charts are in the service facts. And again, the only one that has to be done by volts DC is the suction pressure line. So if you're showing 101 on your suction pressure, 1.52 volts DC across pins 7 and 8. So these two pins right here, if it's 101 suction pressure, better be 1.52 volts DC. So a lot of information in these charts. Excuse me. And each sensor comes into play. Like I said, there's only 5 of them. So if you already have your probes out, we can go ahead and check them, but you can see how much information the ambient temperature is supplying. So if it's not reading correctly, it's going to be affecting your comfort, your fan speed, your defrost, outdoor EV startup, indoor EV position, your preheater. Quite a bit can be affected by that ambient sensor. High temperature protections. Excuse me, discharge temperature. So if that compressor in heating mode goes above 235, it's going to have a shutdown. It releases or resets back at 210. So if we're not reading correctly and it's reading higher than 235, we're going to get an alert, which in some cases that does happen, and go into soft lockout. So we want to verify if we take a pipe clamp here and it's only 150, which is a normal reading, and this is reading 250, we got a bad discharge temperature sensor. And then we can verify it with volts DC, what it's actually reading. High pressure protections are going to land right there on the MOC board. Low suction pressure cuts out 32 PSI in heating. Excuse me. If variable speed site discharge suction reaches 50 PSI in cooling or 25 PSI in the heating mode, the drive will shut down the outdoor unit. So that's critical. We got to verify if our low suction pressure transducer is reading correctly, because we'll get these lockouts. If you've ever considered the crankcase heater on variable speeds, so your heat pumps, 14, 15, and 16 SEER heat pumps, you have to have crankcase heaters. And those crankcase sump pump heaters are connected right into the line voltage. So it's getting continual voltage. With the variable speeds, there's an algorithm that uses the value to turn off and on the preheat. So it's using the compressor windings along with the ambient sensor and the coil temperature sensor and the discharge sensor to detect if it needs to warm that compressor up. So if the outdoor temperature is below 80 degrees, that compressor dome temperature is less than the outdoor ambient temperature, it's going to energize your sump heat on, and it's going to pre-warm that compressor. So it is not a bad idea. As soon as you get electrical on new installs connected to the outdoor unit, cycle the power on so it starts warming. Don't land the communication wires yet, but you can start preheating that compressor. Here's a closer look at those pins. Here's our MOC to AOC harness. Drive diagnostic LEDs. Again, I don't usually use those much because the AOC is going to display them for me, or the thermostat. Again, here's that data plate for the variable speed drive. We're going to need that if we're doing a drive replacement. Condenser fan motor is 3-phase. Here's our drive cooling loop. This is in our variable speed book, which I'll show a picture of it at the end, and I can send you the PDF. So if you do want a PDF version of the Advanced Variable Speed Diagnostics book, go ahead. If you want to put your email in the chat message line, I can email you a PDF copy. But if no LEDs are lighting on the AOC or MOC, no drive lights, it gives you a nice flow chart. Check incoming line. Is line voltage present? If there's no line voltage present, then it's something upstream. You're going to probably have to call an electrician, or it could be the disconnect fuses. Here's our 240 test points, replace driver AOC. Right, so it's a great flow chart to read through 1 time, 2 times, 3 times. If you're like me, you got to read through it 3 times. Mark Alkire put this together a while back. I do have a outdoor variable speed recommendations. Install an AHRI rated system. So we need to make sure that we have an AHRI rated system, especially with the variable speeds. We still get calls with mixed match systems with keeping existing indoor coils, matching them up to outdoor units, and the indoor coils are labeled 3-ton, but they do not match our cubicle volume. So we're trying to put all the refrigerant in from a 3-ton outdoor unit. We're forcing it into a too small of evaporator coil, which is causing head pressure spikes and heating. So that's why we say AHRI rated. If it's not an AHRI rated system, it's possible you're going to have issues. You're going to set the TAM9, TAM8 electric heat size at the air handler CDA before performing the test. So or else you'll get that configuration fault. So you always want to set those electric heat size first thing you do as soon as you power up. Heat sink the TAM9 ATGT sensors and utilize nitrogen when brazing. So that means our sensors in the TAM9 on the coils where you're going to braze, you're going to disconnect those from the actual line. So when you're heating that up with nitrogen, you're not cooking that sensor. We still get calls on it. The guys cooking that sensor, and we can tell if it's not going to read correctly. So you're going to have to automatically change out that sensor. Install the factory supplied liquid line dryer and utilize nitrogen when brazing. I didn't touch too much on it in this one, but nitrogen's a must. If you're not using nitrogen while brazing, you have to. Evacuate the line set and coil to 500 microns and hold for at least 1 minute before releasing. You got to do a good vacuum. Do not add any charge to the indoor coil or line set before opening refrigerant lines. Add extra refrigerant if needed when performing the system startup through the variable speed test mode and technician access. Again, we do not recommend adding charge because of it's set for a certain coil, and we install so many different AHRI matches that it's not precise. Fire off system through the variable speed test mode. And then you're going to charge the subcooling and heating pressure curves. So in cooling, you're going to charge the subcooling, or you're going to use the heating pressure curves found in the service facts. Of course, you want to perform a comprehensive system startup and record all pertinent information, which I have a startup sheet I'll show you. Instruct the customer on usage. I know when I was installing, I'd always leave at least a half hour to go through the controller with the homeowner. It just eliminates some callbacks, and the homeowner won't retain all the information you give them, but at least they can start navigating and walking through it, because you know some of these homeowners are not very technical savvy one bit. Enable and connect the Wi-Fi and enroll the control in Nexia and Dealer Diagnostics. This is huge because if we do have any issues, you can share that AUID number with us here at tech support, or somebody in the office can actually log into it and decipher the information the past 30 days. The past 30 days of runtime. So it's really a valuable diagnostic tool. And we can also see if possibly the homeowner's not changing their filter through static pressure. Upgrade the software, the most current version. This is actually 596 now. It's done by thumb drive or wirelessly. Right now it's still thumb drive on the variable speed CL2 Comfort Link communicating platform. With the link, it's going to be done through wirelessly. Enable optimal snart or aggressive recovery for heat strips. We do recommend setting that aggressive recovery if we have heat strips, because it'll turn that heat strip on and satisfy the home quicker. Set the EAC power level on communicating ESC. Set up accessories options. Well, we didn't touch on that too much, but you can set that to high to increase the filtration. S9V2 must be set at 400 CFM per ton when firing off and checking charge. That's a must. Make sure if we're doing an S9V2, we have to change that to 400 CFM per ton, because factory default's 350. It is possible we go out on head pressure because we're only running at 350 CFM per ton if it's not moving enough air. Set your electric heat, auxiliary heat lockouts. Again, this is just recommendations. Set the compressor lockout, set quiet mode, set defrost termination factory. Again, I have a printout, so if you'd like this emailed to you too, it's just a checklist that you can give out to any new installers, any seasoned installers, just to go through and confirm that they are completing everything. Get the variable speed technical service manual, which I have a copy of that. Write down and save in your phone Gensco tech support. This is for Trane, American Standard, and Mitsubishi. No more Rheem, but Trane, American Standard, and Mitsubishi. If anybody wants copies of our variable speed startup sheet or the zoning one, again, this is something we ask for if we do have an issue after the installation startup. I'm going to ask for a startup sheet, because we're going to submit it to factory. We want to verify that the system has been started up within parameters. So if we do have a failure 6 months down the line, was it started up correctly? Is there an overcharge? What was the subcooling? We can tell a lot from that data. And also, as you fill out the data and you get familiar with a properly running system, if you have a system that's not working correctly, you can quickly identify it because it doesn't fit into your. I know when I first started, if I had a good system, I would write down all my notes and what it should be on a certain day or whatnot. And then if I had a system that wasn't acting right, I'd refer to my properly working system. So that helped me in the beginning, determining my numbers that I should be looking at. Here's the service manual I can send out. I'll get one to you, Juan. And if anybody else wants one, put your, it goes into a deeper dive on the variable speeds, and it has all the systems in there. So it is a good book to have. And then wrapping up, if you guys have any questions, and if nobody's taken advantage of fieldtechhelp.com, please take advantage of fieldtechhelp.com, because the factory puts on great tutorial videos from 5-minute drive replacement videos to 4-hour TXV diagnostics and refrigerant diagnostics with Eric Weiss from the factory. The way he verbally teaches you is great, in my opinion. But fieldtechhelp.com, it's free to you guys. Everybody going into the link will have to have the app and also an AS DealerNet login and Comfort Site login, or a Comfort Site login. Sorry, if your train is comfortsite.com, American Standard will be AMS DealerNet. If you have your login, you can log in to fieldtechhelp.com and you can actually go through and save any videos that you want to use or go through in the future. So you can go through one day a bunch on variable speed or link stuff, and you can save it to your queue. If you're a manager, you can actually assign homework. And to all you new guys out there, I wish this was available to me when I was in the field, because it would have sped me up, because the more you know, the more valuable you are. So you have all these resources. It's like a YouTube for HVAC train American Standard. So take advantage of it. Go through it and start watching each video. You got to watch it 3 times, so be it. Start doing it whenever you get a free time. Instead of watching a YouTube video, go to your fieldtechhelp.com, watch an HVAC video. But that's all I have for you guys. Do you have any other questions? Yes, Stephen, I will get that to you, but I will need, I don't know if I have your, you know what? I will type in my email address and you guys email me. That's my email address. So if you want one of those manuals or want to ask me any questions, feel free to email me and I'll email you back that PDF, because it is valuable information in there to have. Hopefully everybody got something from it today. I'll leave it on for about 2 more minutes to see if we have any questions. Thank you everybody for coming out, by the way.